Here's what we have so far. To generate the derivatives of remaining trigonometric functions, you can take a peek at the definition involving the limit of difference quotient, evoke the addition angle identity for the cosine function, use the other small components we already had to prove that this is true, and you'll find out that the derivative of the cosine of x is likewise the sine of x, but with a sign change. As far as the tangent function's derivative, well, notice I already have the derivative of these two. That being the case, let me rewrite that in terms of our basic building blocks. And now let me use the quotient one. Here's the bottom times the top minus the top times the denominator, but that would be a negative sine of x. Now, I have not committed any mathematical errors, but I gotta confess, the second Pythagorean identity, intimately related to cosine, excuse me, can I rephrase that? The second Pythagorean identity was an intimate relationship between the tangent function and the secant function. So just to maintain those intimate relationships, how about if I just rewrite this as such? And now let me make it official. I now have that the derivative of tangent of x is just secant squared of x. Using a very similar argument, you get something very similar over here, but with a sign change. Now to differentiate this, let me again rewrite in terms of my basic building blocks. And then the chain, excuse me, and then the quotient one. But again, because the intimate relationship between secant and tangent was rewrite. There's a tangent. There's a secant. So from now on, I think of the derivative of secant of x as merely the product of the secant of x with the tangent of x. You will find something very similar here using the same logic. But again, with the sign change. We now have the derivatives of some functions which we haven't been able to differentiate so far. So we are increasing our list of functions for which we're able to differentiate.